Okay, another topic that needs to be mastered by the end of the quarter is using completing the square to rewrite things in vertex form, to rewrite these quadratics in vertex form. So you see in part A, and in class we used those tiles when we first learned how to do this, but now I'm going to use a shortcut because I think everybody's ready for that at this point. Basically, we want to get down to is y equals something squared, x minus something, or x plus something squared plus something. Because remember, vertex form in general looks like this. And so that's what we want to get our answer to look like. It's just what goes here and what goes here and what goes here. The a, h, and k values are the things we have to find. A is easy because you can just look at the problem. So A in this case is 1, or you don't have to write it because 1 times anything is itself. So that part we shouldn't have any trouble with. Now the thing is we have to rewrite this problem, but we still have to maintain that it's equivalent to x squared minus 6x plus 2. So what I want to do is I want to think about just this part here, x squared minus 6x, and how I might write that as something x minus something squared. And what we decided in class after using the tiles is that number always turned out to be half of this number. So I'm going to put a 3 there. But of course, x minus 3 squared is really x squared minus 6x plus 9. So now I have this plus 9 in here that I don't need. So I can get rid of that plus 9 by just minusing 9 off the end here. So now if I were to solve this x minus 3 squared plus 2 minus 9, I'd be right back to x squared minus 6x plus 2. So my answer, x minus 3 squared plus negative 7, or we could write y equals x minus 3 squared minus 7. The vertex then we can see is at 3, negative 7. Okay, the next problem is a little bit different because you can see that the b value here is actually an odd number. But that's not a big deal. We can still use the shortcut. Something squared. So I'm just rewriting that. I'm going to use a shortcut and I'm going to say this has to be half of, so it's going to be x minus 2.5 because half of 5 is 2.5. But in reality, x minus 2.5 squared is x squared minus 5x, which I needed, but now plus 6.25. I don't need that plus 6.25, so I'm going to subtract it off. So now I end up with y equals x minus 2.5 squared plus 1.25. And now it's in vertex form, so I could see the vertex in this case would be 2.5, negative 1.25. Okay, the last problem's by far the trickiest, and that's because now you do have an a value. So the first thing I'm going to do is I'm going to think about this problem. I'm just going to pull that a value out. This is sort of using backwards distributive property. So 3 times what would be 3x squared? And then minus 3 times what would give me 6x? Okay, and now I'm just going to let that 3 kind of sit out there. I'm going to think about how I could rewrite this x minus 2x, but make it or x squared minus 2x, but make it a perfect square. So again, I'm going to use my shortcut. Just take half of that, so x minus 1 squared. But really what I did there is I have the x squared minus 2x, but I'm also adding 1, so I have to subtract 1. But remember, we did pull that 3 out, so really I'm not subtracting 1, I'm subtracting 3. So I have x minus 1 squared minus 3 plus 5. So the key there is to take the number that you would normally subtract, which in our case was 1, but you have to multiply it by the number you pulled out in the beginning. So in this case, we had to multiply it by 3. So my final answer, 3 times x minus 1 squared plus 2, because then I can just combine those together. Okay, good luck with that.